Day and welcome back to online class with Ajibola. The link to the website is onlineclasswithajibola.simdiv.com. Our subject for today is physics and the topic we'll be looking at is motion. At first, what is motion? Motion is the change in the position of an object. The change in the position of a body or of an object. Consider the object at position A. This object is at position A. If nothing changes the position, it will not change, it will remain there. But if it translates or moves to point B, then we say the object is no longer in this position, but the position has changed. That means this object has undergone what is called motion. Now, if the object does not undergo motion, then the position will not change. And that leads to what is called types of motion. Now, types of motion. You remember we said motion is a change in position of an object. So if there's no change in position of an object, that object has not undergone motion. But this object here has undergone motion, moving from point A to point B. Now, two types of motion. The first type we'll be looking at is what is called oscillatory or vibratory motion. Oscillatory or vibratory motion. This is a to and fro motion of an object from its mean or rest position. I take that again. Oscillatory motion is a to and fro motion of an object from its mean position or from its rest position. Consider this diagram. The simple pendulum bob is tied to a rope and the rope is tied to a point. If nothing is moving the bob, it will remain there, then no motion is taking place. But if you slightly hold the bob and you displace it towards the left or to the right, towards this direction, the rope will not remain here. Then you have the pattern of the rope following you here. Then this will be where your bob will form. As the bob is formed here, if you release your hand, what happens? The ball continues to move to and fro. Then you have some kind of motion of the rope along this path and motion of the rope also along the other path, like this. Then you won't have the bob in one position. The bob comes like this, it comes like this, then it reaches here, it won't stop, then it's continue going, it continues to go, it continues to go. So you see it moving to and fro, moving to and fro, and that is what is known as oscillatory or vibratory motion. Now we're going to look at some examples of oscillatory motion. Number one example we're looking at is the simple pendulum. And we can get that in the pendulum clock, okay, and an example that I've just shown you. Then number two is the strings in musical instruments. An example is a guitar. The strings in musical instrument. While the number three is the spring balance. The spring balance. So the motion of the spring balance is oscillatory. It's oscillatory because it moves to and fro. Then the next one is cosmology models. And when we talk about cosmologies, what are we talking about? We're talking about the planetary bodies, we're talking about the existence of the universe, the movement of particles in the space. So we move to the next one, which is called translational motion. Translational motion. What are we talking about when we say translational motion? It is the motion in which all points of a moving object move in uniform direction. Or we say they move uniformly in the same line or direction. I take that again. Translational motion is the motion in which all the points of a moving object move uniformly in the same line or in the same direction. Consider a moving car. It is moving along a straight road, not at a roundabout, but along a straight road. So if it moves from point P here, it moves and gets to point Q. So the motion it has undergone to move from point P all the way to point Q is what is called translational motion. Why is it translational? We said all the parts of the object are in the same position from the beginning of the journey to the end of the journey. Let's take for instance the steering is at the front when the journey began, and when the journey ended, the steering is still at the front. The back wheel is at the back, and the back wheel is still at the back. The right door is on the right, then the right door is still at the right. The right door is here, the right door is still here, and the left side. So all the parts of that object do not change, but they move in uniform direction. They move in a straight line direction. You can imagine if a car is to turn roundabout, you will tell me the steering that is at the front will be facing the other side if it's something like a round motion. But it's not a round one, it is translational motion. So that is translational motion. The movement of an object in a way that all the points of that moving object move uniformly in the same line or direction. That is called translational motion. And examples of translational motion includes, number one, a bullet fired from a gun. Because of the speed with which the bullet is going to move, it's going to move in a translational manner. It's going to undergo what is called translational motion. So the next one is a car moving on a straight line, just like the example you see above, a car moving on a straight line. Then the next one is motion of bees, as they jump from flower to flower, or motion of butterfly as they jump from flower to flower. They don't turn around, they just jump, they move, from one flower to the other when they are pollinating the flowers. Then the last one there that I mentioned is a wooden block being pushed along an horizontal plane. It's horizontal, it's not a vertical plane, it's a horizontal plane, so it goes along a straight line. Then we're going to look at one more example of motion, and that example is what is called rotational motion. You've heard the word rotation before, rotational motion. So rotational motion is the motion, it is the motion of an object in concentric circles. Rotational motion is the motion of an object in concentric circles, the movement of an object around a center or around a grid or around a fixed point. That is what is called rotational motion. Then example is, number one, the blades of a fan in motion. Consider a ceiling fan or a standing fan. When the blades are in motion, though the fan itself did not move. It didn't move from one room to another or from one point to another, but the blades are moving. The blades are not static. They are moving. They are moving. They are rotating in a fixed manner. Then the next example there is the wheels of an automobile in motion. The wheels of a bicycle, the wheels of a bike, the wheels of a truck, the wheels of a car. All those are what is called the example of rotational motion. Then the next example is the belt of a grinding machine. If you have ever witnessed where a grinding machine is working before, when you start the grinding machine, the belt starts rotating. It starts rotating. It doesn't move away from the machine, but it's rotating about a fixed point. Then the next motion, and the next example is the motion of planetary bodies. The Earth, the stars, the satellites, the moon, and the likes. So, right now, we've been able to look at motion. We said motion is the change in position of an object. Then we consider an object changing from one position to the other. And we looked at the types of motion. The type we have looked at is oscillatory motion. The next type is translational motion. And the last type we looked at is rotational motion. Now you have an assignment here. The assignment to do is to explain any other type of motion with one example. Look for any other type of motion with one example and explain it. You are going to submit. Then the number two is that on all the motions that have been mentioned, which is oscillatory, translational, and rotational, you are to mention two other examples of such motion apart from all the examples that have been mentioned. You have to mention two other examples of oscillatory motion, two other examples of translational motion, and two other examples of rotational motion. Thank you very much for listening. I will be expecting you to submit your assignment. See you.